All right, let's get started. Good afternoon, everybody. My name is Tim Mooney. I'm the Communications and Marketing Manager for the Rhode Island chapter of the Nature Conservancy, and thank you for joining our conversation today. I want to start by saying hello to the Nature Conservancy donors and trustees who are in the audience with us today. Thank you all so much. We're very grateful for your support and your continued interest in our work here in Rhode Island. Leading up to this presentation, we've also had a lot of interest from our partners, the state agencies, the community organizations, the private companies who are all working on clean water and coastal habitat restoration projects. Indeed, the work we're going to talk about today at Rose Larissa Park in East Providence is the result of a very strong partnership that is one between the Nature Conservancy, Rhode Island CRMC, NOAA, and the City of East Providence. And if you're not familiar with Rose, we're going to hear a lot about Rose Larissa Park on the shores of the Upper Narragansett Bay. Where is Rose Larissa Park if you're not from East Providence? Well, if you're from Rhode Island, it's where Crescent Park used to be. So we all have our, our historical and geographical bearings before we get started. Quick housekeeping note for the talk. Today's presentation will run for about an hour, including plenty of time for questions and answers. I have muted everybody, and that will be true for the duration of the presentation. Everybody is muted except for the presenters. But you can certainly type your questions into the Q&A box that is at the bottom of your screen. You do not have to be a coastal engineer or a coastal scientist to ask a question, although we have some in the audience, and we hope that you will speak up with things that are of interest to you. I have a whole list of dumb questions to ask, so please fire away. To kick off the program, I want to welcome the State Director of the Nature Conservancy, John Horgan. John has been the State Director for the past 3 years and is leading of a team here of about 25 people. John is a native Rhode Islander, and he's a longtime champion of the Providence River, that part of Narragansett Bay that is surrounded by the Providence metro area. John knows every inch of the shoreline, and he knows where the stripers hang out too. John, take it away.
Thank you, Tim. Good afternoon, everyone. Coastal erosion and sea level rise are already dramatically impacting coastal cities and communities in the Northeast and here in Rhode Island. The historic practices of hard armoring using rock and sheet pile revetment of the shoreline can degrade fish and wildlife habitat, increase erosion for the neighbors, and diminish public access to the shore, something we treasure in Rhode Island. And along much of Rhode Island's coast, this kind of hard shoreline protection is prohibited, leaving property owners and municipalities no real recourse in the face of increasing storms, ever higher high tides, and diminishing salt marshes and coastal wetlands. The idea of using a living shoreline is not new, having been used in the South and the Mid-Atlantic now for decades, where there is a longer growing season and where there's no ice and no severe winters. Living shorelines are about using nature-based strategies that employ a combination of structures to help slow the erosion, planted with native grasses, and in some cases using shellfish and shells, not in this case, all to improve habitat value, to make it beautiful, and to make it more resilient in the face of a changing climate. The Rose Larissa Park project in East Providence is a great local example of how we can apply this concept in a way that benefits nature, and it also has great benefits to people who come down and enjoy the shore. All people are welcome to come down and see this. This project, as Tim was saying, is the result of a collaborative partnership between the Nature Conservancy, Rhode Island CRMC, and NOAA, and funded by 11th Hour Racing, helped by the City of East Providence, and supported by the Rhode Island Coastal Habitat Estuary Restoration Fund. To tell you about this project and answer your questions today, we have two of the top experts in the field. My colleague John O'Brien is a senior policy and partnership leader at the Nature Conservancy here in Rhode Island. John has made a distinguished career of more than 50 years in Rhode Island in service of conservation, public access, and fish and wildlife. And he still gets done before 9 in the morning, then I get done all week. So I'm happy to have John here. And Janet Friedman. Janet Friedman is a coastal geologist with the Rhode Island Coastal Resources Management Council, whom I have known and worked closely with for many years. And Janet is an expert on coastal erosion and coastal processes in Rhode Island. She was talking about the need for these kinds of solutions many years ago, long before it became a hot topic. And we understand that sometime later this year, Janet will be retiring from Rhode Island CRMC and public service after more than 2 decades of great and honorable service to the state. So we are just so lucky to have her with us today to share her wisdom and her perspective on these issues. And I'm going to turn it back to you, Tim.
Great, thank you, JT. So we're going to do something a little different. First, we're going to show a news story that ran about the project, ran on Channel 12 a few weeks ago. Pete Mangione came out and visited with us one afternoon. This is going to take a minute to get right, but bear with me. I tried to cue this up better, it just didn't work out. There's unfortunately is going to be about a 15-second ad at the beginning of the clip, but it will set the stage and give you a good overview of what we're going to talk about today. See, now we're in the ad part already. Isn't this exciting? A live Zoom. It's coming. Oh, there it is. Whoops.
At the Skydrone 12 over Rose Larissa Park in East Providence, just behind the beautiful beach, erosion has taken a toll on these bluffs.
Intuition's moisturizing body
Yikes.
lathers and shapes and
foiled.
making shower time me time. Just Jillian's
This
time.
worked really well in rehearsal.
Email time. Just Jillian's. Intuition.
He'll be back.
All you need.
What we're trying to figure out is whether nature-based solutions are being more effective at controlling coastal erosion than concrete walls and sheet piling.
Tim Mooney from the Rhode Island Nature Conservancy says a seawall previously here failed. So it's time to get creative with things like logs made of coconut fiber. But that's just the beginning, because biodegradable material can be stitched and sewn together in all types of ways.
Some of them are in the form of a blanket that we put down over the sand that will protect salt marsh plants.
Native vegetation will be planted along part of the bluff and along the southern boundary of the park. A combination of stone, sand, and salt marsh plants will reinforce the protection. While projects like this have become common around the country, this is one of the very few in New England. It's a team effort that includes 11th Hour Racing from Newport, the Coastal Resource Management Council, URI, and the City of Providence.
If you have a coastal property and you see your property crumbling away, there's really very little that can be done about that.
The hope is that this nature-infused protective shield will change that, at least along the shore. Construction for this project will be finished on Friday, but it will be monitored for several years to see how the restoration holds up. I'm meteorologist Pete Mangione, Eyewitness News.
Tim, before we go to the panelists, there's one other thing I meant to tell, which is the story of how we got to this. A number of years ago, there was a NOAA grant for the New England coastal states to really think about state-of-the-art best practices in living shoreline policy and application. And that led to another NOAA grant that the New England coastal states were a part of to do some actual projects to test some of these principles that we were looking at in the first stage. And so a number of different states came forward to illustrate these practices, to use some common metrics and monitoring so that we can learn from the application and inform future practice, and we hope at a larger scale. So that's some of the background. And I see Steve Kirk is on the call and Eric Roberts from the Nature Conservancy in Massachusetts. And you guys were really key to making this all possible too. So I just want to recognize you and thank you.
Thanks, JT, for adding that. Okay, so and wasn't that exciting having an ad pop up in the middle of the video? You never know what you're going to get. Let's dive into the project itself and take advantage of having someone as smart as Janet on the call with us. And Janet, I'm going to set up some slides that show the park. And can you help us understand what is a coastal bluff? Why is it eroding? What is the problem that we're trying to solve, and why did TNC and CRMC work at this site in East Providence?
Yeah, well, thank you for. I'll try to live up to your expectation that I will be actually able to tell you something worthwhile. But this is an eroding bluff at Rose Larissa. It's a pretty steep, it's an oversteepened bluff. It's pretty high compared to a lot of the shoreline along Rhode Island. So that brings really special challenges. This is a bluff that formed 20,000 years ago, 20,000 years ago. If you want to go back in the Wayback Machine, this area was covered with an ice sheet. So if people can think of what the pictures you see of Greenland today, that's kind of what this looked like. As the ice retreated, you had meltwater coming out, and all the sand and gravel and other sediment particles that had been scooped up under the ice were released through meltwater channels, and it formed these deltas into glacial Lake Narragansett. Brian Oakley, I think, is on the call, and he's
Yes.
really an expert. So I will, he could go into much more detail about this process. But consequently, you have these sand bluffs. They're not the worst case scenario where you have a mixture of different sediment types, but they're really steep bluffs that are eroding as the storm waves impact the base of the slope. They'll undercut the base of the slope through erosion. And then you can see in this photo that there's trees and looks like a remnant of a stone wall, as well as other things that were thrown over the bluff. All of that creates, gravity just takes over. So when you have these trees fall out, you can see in this photo that they are leaning. When these trees go, they take a lot of sediment out of the bluff with them. So it's a constant process. It's really storm driven, that when you have big storms, the waves are able to impact that coast. It undercuts the bluff base, and then, through gravity, you just end up losing the top of the bluff.
So from there, if we could move on to note that this is not the project that we worked on last month is not the first attempt at trying to deal with erosion on the bluff, right?
Oh no, and yeah, we've had, when we looked at the project, when we went out to the site, there were so many different attempts at erosion control over the years that you can see. This is an example of a concrete seawall that had collapsed, probably by wave action that overtopped the wall, and eventually it was just undercut and fell. But there's also wooden bulkheads that you see. There's a lot of riprap, and yet the bluffs keep eroding. So we know that they have taken over time, people have tried hard solutions. Hard solutions work for a while, but they're not permanent solutions. And so we thought that we would see on this beach if we could try something else. We have done, nature-based infrastructure in other areas around the state. In this case, the bluffs are really high and they're the most challenging. So this is kind of a first in that sense. And the nature-based infrastructure is good, that it will, hopefully we will curtail some of the bluff erosion, but at the same time create habitat and get those ecosystem benefits.
Great, thank you, Janet. That's perfect. John, I want to switch to you and to talk about what those. We tried two different approaches on this stretch of shoreline. The first one was an effort to work directly on the bluff and to augment and stabilize the bluff itself. Can you walk us through the construction process?
Yeah, actually, just let me start with the scale. The exposed area of Rosa Larissa Park is about 850 linear feet as it goes from one end to the other. We are talking about the application of two test practices. The first of which is over a 100-foot section, and it's called a core log revetment. Now, just to go back, we approached this with what's called a design-build piece of engineering. We reached out with Sumco Eco Contracting. Actually, we awarded the contract to them, and they reached out to GZA for the design. And they pooled their resources together and all of the experience that they have with bluff erosion, and came up with the two different practices that we are testing. The first of which we're talking about is the core log revetment. And I will say that, I must say that the project, while it was underway, Sumco was extremely cooperative, responsive, easy to work with, and prompt to inform and report us on all aspects of this. It was absolutely amazing to watch this take place. It was done over a 3-week period. I think we started the 27th of April, and we were out of there on the 15th of May. Now, the core log revetment work began by clearing vegetation, including trees, and then landscaping the bluff to a 1/1.5 slope. And that's a little less steep than what the existing bluff was. And then you can see where a trough was excavated and a rock toe was constructed at the base of this with a 12 to 24 inch riprap. And that was over a bed of crushed stone. And that toe extended up about 6 feet along the slope of the bluff. And that gave way to a network of core logs that were laid above the rock toe. The rock toe is actually the primary structure to absorb the force of high wave energy. And what you see here are the core logs. They're 20 inches in diameter and about 10 feet long. And they're set over a standard polyester filter fabric. The core logs are constructed from it's densely packed coconut husk fiber and encased in a very coarsely woven fabric made from coconut husk fiber. Each log was then secured to the bluff with steel cables. These cables were anchored down approximately 6 feet, and you see here the process of using a vibrator or just a hand-operated vibrator, which pushed the anchor down 6 feet into the slope, and then the core logs were wrapped and stabilized. Now that the combination of both the rock toe and the core log bluff measured approximately 30 feet up the slope. After that, the core logs were covered with 6 inches of fresh sand, and a tough core fabric was stretched over the sand. And then finally, I think it was about 3,000 bare root plants of beach grass was set through the fabric and into the sand to complete the stable slope. So at the same time, both of these projects were constructed together. We'll go to the intertidal sill and marsh. That was constructed during low tide. Because of the permitting, we were restricted to just working at low tide. And it was back and forth with the excavator between the core log revetment and constructing the sills. But again, I think the measurements of the sills was about 28. There were 4 of them, and they were about 28 feet long and 12 feet wide. Now, this was at the southern end of the beach, and it was about 130-foot stretch of the beach. The 12 to 24-inch riprap was placed over this crushed stone, and they were set at, I think, and Janet, you can correct me, I think it's the approximate location was mid-tide.
Yes.
The height or top of the sills was set at an elevation of 2.5 above mean seawater, and each sill was separated by 5 feet in order to allow for the marsh to drain on the receding tide. And after the intertidal sills were constructed, about a foot of marsh fill was brought in and spread over the back to about 30, I think it was about 30 feet from the sill to the base of the bluff. Half of that was covered with a fabric to reduce beach erosion, and the other half was left uncovered. Again, this is a test. Both were planted with marsh grass. I think we planted a total of 2,000 plugs, 2-inch plugs. After that, fencing was installed to reduce the predation by Canadian geese. And that's it for a real quick walkthrough of the construction process, and I'm sure that there may be questions that might come, and I think our contractors, both GZA and Sumco, are on the call, and maybe they might join in.
Okay. Thank you, John. That was great. What you don't see in the slides is the loader whizzing up and down the beach, moving material to keep both job sites active at the same time. It was a highly coordinated dance on a narrow stretch of a beach in East Providence, and like you said, it all came together very quickly. So I'll stop sharing, and now I can see see if there are questions.
And there was one question, Tim, that I did about whether this required a special exception from CRNC. And no, it did not, because it's classified as a type 2 shoreline, so that the structural shoreline protection is allowed along this type shoreline. It did require an Army Corps of Engineers permit and a water quality certificate. And one of the things on the sill, we had to tide coordinate the construction of it, which was really tricky. We had 1 week that the tides were good, but another one, I think the contractors came at like 4 in the morning because they wanted to work in the dry period. So we could not work when in the water, but we could work on the beach when it was dry.
And Janet, just something you said reminded me of in terms of people being able to put structures on that stretch of shoreline. you want to touch on the inspiration for why are we trying to plant a marsh on a beach?
Yeah, we're trying to do this because there are structures all along the shoreline. Oh, sorry. There are structures all along the shoreline already, and so they oh, wait a minute, sorry. So people can build them, and the structures here, if you walk along the shoreline, there are people have done all sorts of things over the years. Some of them are effective, some of them are not. A lot of them are crumbling. I think we've had 47 applications for new shoreline structure within a mile of this site. So people are building the structures. A structure itself is going, it may protect the house on the bluff, but the beach will narrow, especially with sea level rise. I mean, we've already seen in many areas you can only walk along this beach at low tide, that we need to come up with some other alternative to just putting in a seawall and taking away the public access on the beach. This is something where we're looking to see, are there other opportunities? Are there different things that we can do that will protect the bluff, but will also, allow some habitat and hopefully some public access. But the writing's on the wall, the beach is narrowing, unless we move all the houses back. This is gonna keep, we're gonna lose more and more beach over time.
So Janet, Brian Oakley chimed in with a question in the chat on your point. He asks, if the Bluff project were to be extended, is there any thought to add sediment to the shoreline to account for the sediment lost to the system now that the bluff erosion, which is the source of sediment to the beach, is limited?
Well, that's a good question. We have some opportunities there with beneficial reuse of dredge material. Right now, we haven't looked at that. Beach replenishment is very expensive, but I think in the future it's a good candidate to look at if there are dredging projects nearby and the sediment is appropriate for beach restoration and it's clean, then it's a good place to be able to dispose of the sediment while creating a good beach habitat. It's something to look at in the future. We haven't looked at it yet, but future dredging opportunities may end up giving us some sand source.
Great, thank you, Janet. There's a question about the beach grass that was planted on the on the bluff, on the over the core logs. Question is, well, how will the beach grass propagate? Will it fill in? I think is a question. And does it come from underground, or how do you get more beach grass on the bluff? Either John or Janet.
Well, the beach grass will fill in. Beach grass grows from the root system down the vertical root system, but it also has rhizomes, so it sends outside shoots and it will fill in. And the beach grass, I was out there yesterday. The beach grass is looking green now, which is good. It looks like it's doing pretty well, and hopefully in a few years that the bank will be covered with beach grass. Beach grass, the root systems, if you step on it, you can break the root systems and kill the beach grass that way. But I don't anticipate very many people trying to climb up on the bluff and breaking the roots.
Yeah, I feel like when we were talking with the contractor about what it was going to look like going forward, if anything was going to work, it was going to be the survival of the beach grass. Like that was the lowest, that was the low bar. Putting beach grass in sand probably is going to be okay. And so for the rest of it, there's a question about monitoring and how will we know if this is working, and how and when will we know if this has worked? And what does working even mean?
Well, this is designed, it's not designed for a 100-year storm. So I'm really hoping we don't get that anytime soon. But it's really stormed, and we can tell how it's working if it survives a big storm, a fairly big storm, perhaps like an Irene, maybe a Sandy, and we won't know, we can't predict the storm schedule. So we're going to monitor for 3 years, and we may or may not get a big storm in that period. You know, it really is storm driven. So hopefully we'll be able to monitor a lot longer than that. And we'll get-
John, do you want to talk about the monitoring that we're going to do, the drone photography in partnership with URI, Coastal Engineering, or School of Engineering? You're muted, John.
I'm sorry. I think Janet has been closer to that. It's something that that she brought in, and I think maybe she could address that.
Right. We're working with URI Ocean Engineering. They are doing something, it's called Structure from Motion. And what they do is a drone survey. It's an aerial photograph survey where you have overlapping aerial photographs. And I don't know whether any of you engineers remember in the Wayback Machine when you used to take stereo pairs to do topographic maps. It works on that principle that you overlap the photos and you can build a whole 3D model. So they've already done a pre-construction survey and a post-construction survey, and it's a whole 3D model where they can look at where sediment has accumulated or anything, you know, I mean, they'll be able to see the structures on the beach, and then they can see where there's loss of sediment. So we're doing this. We have a couple of flights that we have targeted to be post-storm, and then at the end of the 3 years, we'll have a final flight to see how the bluff has changed in that time, and as well as how the structures that we have put in have changed.
Great, thank you. There's another couple of questions about cost. And one is the stone, is there any price difference between the armor stone and the core logs?
I don't know what the difference would be. I just know it would be more expensive if you went to armor stone instead of core logs, and then you're losing the whole concept of a living shoreline. The whole concept of establishing vegetation, stabilizing the bluff with established vegetation. And as far as the durability, we've talked about this before. Yes, stone does last a little longer than coconut core fabric. But I think in this case, we're looking at the core log, which, as I understand it, have like a 5 to 10 year lifespan. But the test here is to see if the bluff gets established with a blanket of vegetation, of living stem and root mass that will stabilize the bluff and make it more resistant to the type of energy that is subjected to.
And because as we watched it be constructed, underneath there's a fabric layer underneath the core logs meant to keep the moisture, keep the core logs, I wouldn't say dry, but in order to retard moisture from degrading the core logs before the dune or the bluff has a chance to establish itself. So that, there's that. We have seen through other projects, if you put core logs in the water and exposed to, and they get saturated, they don't last 5 to 10 years. Hoping we have some precautions taken for this to last long enough for the root systems to establish themselves. Is that all right?
Yeah.
Are there any others? So people are asking, so what's next? Are there other places along the Rhode Island shoreline where something like this might be considered or make sense?
Oh, well, we have a project actually going on right now called the Shoreline Adaptation Inventory and Design Project, where we are looking at nature-based infrastructure that has been done and opportunities where you could have nature-based infrastructure. And this is all in an inventory that you can reach by going on our CRMC website under Coastal Resilience. And what we want to do with this is have projects that are ready, have them in an inventory, and then when funding opportunities come up in the future, the projects are already there. We're going into the second phase of that, where we're designing 9 of the projects, and then when there's funding available, they'll be ready to go. So we're looking throughout the state on where nature-based infrastructure can be used.
Great. I mentioned, I skipped over this question, but there was a question about how much did the project cost? I believe the total project cost was $232,000. And we've mentioned this, but I think it's worth repeating that the NOAA grant, while generous and necessary to the project, was not sufficient to pay for everything we did. So we brought in 2 other partners, the Habitat Trust Fund administered by CRMC and 11th Hour Racing, made the difference between one project and 2 projects, or one project now and a project down the road. By virtue of those 2 partners joining and supporting this effort, we're able to do 2 projects with 1 mobilization. What else do we have for questions? There was a question about invasive plants. So when there's obviously there's a lot of, it is a disturbed site to begin with, and then we stirred things up further, and that is a recipe for invasive plant recruitment. Is there any effort, and there certainly are, there's a wall of Japanese knotweed on parts of that bluff. Is that part of what the partners looked at for this project?
Not so much. I mean, we looked at removing a lot of the invasive trees to open up shading. We will, as part of monitoring, if we see the invasives, especially the knotweed extending to the beach grass area, we will probably look at some type of management. But yeah, we didn't really, invasive species wasn't really a part of this. One of the things that, to me, I probably should have known, but it's kind of a surprise, on the marsh area, we have lots of ulva, a lot more ulva than I thought would be on the beach. So I've been trying to seaweed it once a week, and so that it doesn't smother the marsh plants. So that's another issue that's come up. But again, the alterniflora looks pretty good. It's greening up.
So, and by ulva, you mean the bright green strips of seaweed that wash up in the beach and clumps in that part of the bay, right?
Yeah, the sea lettuce.
Sea lettuce, right. John Torgan, you had a question you wanted to ask Janet?
Thanks, Tim. Yeah, it's following up on Dennis Erkin's question, which is, does this require a special exception? And it doesn't, because this is an area where these kinds of activities are already allowed. What about places that are higher level of conservation and protection? Is there a way that we can apply this there, what would the process be like? Is it expressly prohibited, and could we think about this in other places that are suitable in terms of energy, wave energy?
Well, we divide our projects into, there is non-structural, where we will allow you to use biodegradable materials. So we've had projects where people on type 1 shorelines have built dunes with a core envelope core to them to give them a little more structure in storms, or also on some of the bluffs on the South Shore. But the then this, we would classify this as hybrid, where you're using stone elements, traditional stone elements, with other nature-based elements and vegetation and things. So this one would not be allowed on a type 1 shoreline, or it would need a special exception. And then the third phase is, totally structural. And if you're proposing to do shoreline structures, you really have to consider just natural shoreline versus, and then hybrid, and before you go to total structural shoreline.
And then there's the next question, because same question from a couple people who have asked about noting that, as John O'Brien pointed out, we treated about 230 feet of more than 800 feet of park shoreline and more in terms of the length of the bluff. So we're trying out these experimental approaches. What about the parts of the bluff that haven't been treated, and will the treated sections have impacts on the untreated sections next to them? How do you look at the areas that have not been treated?
Well, this is where monitoring comes in. We want to see if there are impacts on the sides of these structures. Are we creating more erosion somewhere else? And even, we took out half of the collapsed seawall, but left some, and seeing if that helps or hurts erosion to remove these. So it is all part of the monitoring. And we have having parts of the shoreline, because this is an experiment, it's good to have control sections of the shoreline so we can see, we can really get a handle on whether these are really working or not by comparing the treated areas with the untreated areas. If they work in the future, it could be an option for the rest of the shoreline. We'll see.
Great, thank you. And that was, I think we said it was, Sumco told us it was 50 tons of concrete that came off the beach, hauled away in a dump truck. I will say, one of the, we're trying to apply innovative approaches to coastal erosion and all that, right? And that's great. The coolest part was watching them break up that seawall by picking up big chunks and smash it on the chunks next to it. That was the highlight of the 3 weeks. I'll never forget that. That was actually pretty cool. Someone had a question going back to a couple of questions ago. Janet, could you just remind us what do you mean by a type 1 shoreline? And maybe, so type 1 versus type 2, what do those terms mean?
CRMC we zone our tidal waters, and they range from type 1, which are conservation areas, and also areas that shoreline structures are inappropriate because of the high wave energy. And then our type 6 waters are industrial harbors. So the rest of the waters fall somewhere in between. Type 2 is a low intensity use water. You could put in a dock in a type 2. You could put a shoreline structure, but it's still pretty good water. The highest protection level goes on type 1 waters. And, and then whereas in an industrial port, yes, we absolutely allow shoreline structures, and that's probably the preferred method of creating ports.
Thanks, Janet. We've got about 15 minutes left, and I see at least 3 more questions we haven't gotten to yet, so we're in good shape. If you haven't asked a question yet, if you've been hanging on to one, fire away. We still have time to get to it. One question about the 3 years of monitoring post-construction. The big question is, okay, so then what? Will there be monitoring beyond that? And what might that look like? And also, I will add my own question about the photo posts that are out there. And is there any way for community scientists to contribute?
Well, as far as the Nature Conservancy is concerned, this is in the funding and the interest in this. I would have to say that we will continue to monitor this in some manner after the required 3 years are over. It's too important a project not to look at it over a longer term than 3 years, certainly from our perspective. And Janet, you may want to speak about the monitoring protocol itself a bit. The picture post, as well as the transects that have been set up, and the methodology that will be used.
Yeah, we have there. If you go out there, you'll notice some wooden posts with a funny top on it, which were manufactured by John O'Brien. And what you do is it's an octagon top, and what you do is you take your phone and lean it against the different edges and take a photo. So then we have the photos from the same height, the same angle, and we can use these to monitor changes in the that are going on with the 2 structures. The 2 by the Bluff, I think I would prefer to move them because they were put in before there was vegetation, and now you only get shots of the vegetation. You want to move those out a little bit, but definitely the marsh ones. Anyone who wants to go and take photos, go ahead. We are looking at where we're going to be uploading that yet. We haven't decided on where we'll finally curate those, but go ahead and take some photos, and you can see the progress over time yourself. So we have those. We have other types of monitoring that we're doing. We talked about the structure from motion. We have the picture posts. We have opportunistic photos where we can take closer, lots of different things. Make sure that the integrity of the structures is good, to look at the vegetation. And then in the marsh, we have vegetation transects where we will be taking 1 meter squares. We set up the transect location, so we'll have 4 in the marsh area, 2 in the, we didn't talk about this, but half of the marsh has a core blanket on it, and half of it just has sand. We want to compare the difference between those 2 to see if, it makes it more difficult for the geese to eat the marsh grasses in one or the other, and see which area grows better. Just testing out another, 2 different methods that are used in creating the marsh. So we'll have 4 transects in the marsh area where we actually count the different types of vegetation and look at the density and stem height. And then we also have a transect near the marsh where we're going to be looking at the elevations. And these are all done with an RTK GPS, so that you're getting, both the elevation as well as the, the east-west coordinates.
Mm-hmm. I'm glad you mentioned the blanket and the treatments of the different way we handle the thing that we're testing about, whether the blanket will deter geese from pulling the shoots out. I will say to those who are in the audience, if you like, Save the Bay does this a lot. We are planting salt marsh. If you want to sign up for something like that, if they offer you the option of planting in the sand or planting in the blanket, run to the sand. Much easier putting those salt marsh plants straight into the sand than tucking them in between the holes in the blanket. But we did it, and we had fun too. Pete August has a question about sea level rise. Can the stone? So this is on the core log revetment. Can the stone edge be elevated in the future to accommodate sea level rise and increasing nuisance tides? How adaptable is this over the span of decades?
Well, we didn't plan on, I mean, the design life of this will be, we're hoping, 20 years. The core itself will break down in 7 to 10 years, depending on, the light. Then hopefully the plants take over, but this isn't designed for long term, and so it's not designed for sea level rise. Retrofitting it, I'm not sure. It'd be back to the drawing board with the engineers, I believe. But it is something that, that we're definitely concerned about, and it's going to be right at the edge of it will be in the intertidal area at some time.
I would just offer another thought on that, which is that, sometimes engineers in particular expect or have real concern about something failing. And we understand that in the case of living shorelines, when you're using soft media, recognizing it's a dynamic system, we have to think about like what the risk of failure is and what failure looks like. And so in a case like this, failure may not be as catastrophic as if it were a piece of hard infrastructure that's going to put people at risk in any sort of way, or put bad stuff out into the environment. So if a core log blows out, you have coconut fiber in the river, and that's not a bad thing. So that's part of what the kind of media that come into this are. And the nature of these projects is such that they're relatively low cost to maintain. And I think we would need to think about a long-term maintenance budget that would involve replanting and fixing and adapting to the changes that we know are coming.
Good point, TT. A couple more questions I want to get to. One is, so I'll do one on a regional level and one on a very local level. On the region, JT, you touched on, and maybe others have touched on this as this project at Rose Lewis Park in the context of a coastal New England wide analysis. And can one of you speak to the sort of what we learn? So what we learn here, presumably we will share, and what is learned on the other 14 sites around New England will be shared. And so we know we'll learn something from Rose Lewis Park, but what else do we expect to learn from the NOAA project?
Tim, I think coastal resilience and adaptation is a priority for the Nature Conservancy worldwide, and we are working in close partnership with the other chapters and regions of the Nature Conservancy in advancing the practice. So what we learn here, and even in this webinar, we have colleagues from around the organization looking at it, will be applied in other places where we have similar conditions. And we don't want to claim success before we measure it, but we want to inform future practice based on our experience here. And this one, there were a lot of lessons that we learned from like the ones that we did together in a similar partnership in Narrow River, and learning from the stuff that didn't work, You know, in some cases, the soft structure is too soft for the high energy conditions that we have here. And we have to think about using heavier duty installations to get the effects that we want to see. And all of that informs future practice to make sure that the future projects work better and serve their purpose better. And so this will, I hope, inform. I already on the call this morning told the whole Northeast Division directors about the project from Maine to Maryland and Washington, D.C. So there are eyes on this, and it offers exciting potential, recognizing that these aren't a one-size-fits-all and the conditions have to be suitable to the approach.
Thanks, JT. John O'Brien, one thing we haven't touched on yet is the role of the City of East Providence. You touch on our relationship with the city. So a two-part question. How did the city become involved in the construction? And two, there was a question from the audience about how local residents perceive the work. There were lots of, we met lots of people walking up and down the beach. Any story you can share from that experience?
Yeah, the city was great to work with, very accommodating. This is their park. They're very proud of it, as are all of the city residents that use that park. On any given nice day, you can see people parking and then walking down below or above. We worked very closely with the city engineer, had him on site a couple times as we were starting the project just to go over it and explain it. Very cooperative. Assisted us with a lot of the logistics. And at the same time, they were very generous in the sense that when we were looking at the Bluff revetment, in order to landscape that slope to a 1/1.5, we needed additional sand material, and the city very generously donated 200 cubic yards of sand, actually delivered it to the site. Really made that work. So I think we developed a very, very good relationship with the city. We had a good relationship in the past as we've done a couple of other projects, the artificial reef at Sabin Point. But this worked out well. And as far as the general public is concerned, very interested in and really respected what we were trying to do. The constant walking back and forth, they would stop, they'd ask questions, they would nod their head and say, wow, this is great because everything they've done here in the past hasn't worked. And we're very anxious to see if this would work. Both Janet and I were there every day, and I think you'll agree with me, Janet, that everything was very well received by the public.
Yeah, I would agree, John, and I was pleasantly surprised. I expected some people to want it to be the same as it was, but no, it's really, people are really excited about it or curious about it, and it's been a really nice to see that the people of East Providence really do like it. And also the mayor did come out when we were finishing up to check it out.
Right.
Yeah.
Right.
And it was interesting. As Janet would explain to the residents about various geological processes that were taking place there, I had to listen in too because I learned something, and it was a learning experience. For me. Was very interesting.
Great, thank you. Same for me. I learned a lot, and I have learned a lot in the past hour as well. We're still learning. So with that, it is 1 o'clock. We're going to let our panelists go. I want to thank John, and Janet for being with us and putting this presentation together. I want to thank the audience for the great questions that helped us to dig in a little bit and move the conversation forward. This is, I believe, the third webinar that we've done since the spring. We have more planned, so stay tuned for that. And if you have ideas for what would make a good subject for future webinars, we're all ears. We'd love to hear your ideas on, putting the spotlight on work that we, the Nature Conservancy and our many partners are doing around the state. With that, we look forward to seeing you in person very soon. Thanks so much. Bye.